about titration calculations and how to successfully complete a titration calculation. Okay? Here is what one will look like. If it takes 54 milliliters of 0.1 molar sodium hydroxide to neutralize 125 mils of an HCl solution, what is the concentration of the HCl? Okay, now here's the good news for you students. This looks like a different problem than one we've done before. However, you get to use the exact same formula we did for dilutions, okay? So our formula for titration problems, is actually going to be M1V1 equals M2V2. Now here's what I'm going to tell you. This actually only works for a certain type of titration, but what I'm going to tell you is that the ones that you're going to be given on your quiz, on your test, are just going to be the ones that you can use this formula for. So you're not going to see the ones that you have to do something different, okay? So I just wanted to let you know that this won't always work, but in this class it will, okay? The only difference between this problem and a dilution problem is that for the acid-base problem, you have to have a reaction. You have to actually write out the balanced reaction, because we are titrating sodium hydroxide with hydrochloric acid. We have to see that balanced reaction, okay? So that's the big difference here between dilution problems and titration problems. So we're going to go ahead and do that now. We've got NaOH plus HCl. Remember, we swap partners. This is a double replacement reaction. So now the H plus is going to be with the OH minus. Do you remember HOH is actually water? One of your products for titrations are always going to be H2O. Plus, now we have to combine Na with Cl. Remember to balance charges, okay? Now this one's not going to end up being very hard, but you're going to have to balance charges. So sodium is in group 1, it has a +1 charge. Chloride is a halogen, it's in group 17, has a -1 charge. So we really only need one of each. That's why I told you it's really not that hard on this one, but you should always double check that you are balancing correctly. So it's actually NaCl. Okay? So write your reaction. How do you know that it's a titration problem rather than a dilution problem? There are a few things. If we see the word neutralize, if we see the word titration, or to complete a titration, those are hints that it's going to be a titration problem. Also look, sodium hydroxide and HCl, we have two different solutions. Do you remember with dilutions, we're just talking about adding water to one solution? We're not changing the substance type, okay? Also, dilution problems a lot of times will say dilute, if you dilute this, okay? So those are all hints that it's going to be how to tell the difference between the two, okay? So now let's actually solve this problem. Takes 54 mils of a 0.1 molar solution of sodium hydroxide. That's going to be M1 and V1. So V1 is 54 mils. M1 is 0.1 molar. Okay. To neutralize 125 mils of an HCl solution. That is our V2 because it's our second substance now. 125 mils. And then M2 is, that's what we're trying to find, okay? So there's our unknown, okay? Formula is M1V1 equals M2V2, so let's go ahead and plug and chug. M1 is 0.1, V1 is 54, equals M2, that's what we're trying to find. V2 is 125. Okay? Now, let's do some algebra here. We have to divide both sides by 125 to get that M2 by itself. So those actually cancel, okay? And we end up with 0.1 times 54 divided by 125, and we get 0.04 molar. And there's our answer. Remember that the unit is a capital M and it has to be after the answer, okay? If you had written m equals 0.04, you would have just lost a point for your unit. That is not correct. Make sure you have the m afterwards. So that is our concentration of the HCl. Notice we just, here, they did a titration in order to find an unknown concentration. That's the whole point of doing a titration. Let's go ahead and do one more. Now I'm going to work one more example with you guys about calculating for titration problems. So here it is. If it takes 25 mils of 0.05 molar HCl to neutralize 345 mils of a sodium hydroxide solution, what is the concentration of the sodium hydroxide solution? So some keywords, if you see the word neutralize, or if you see two different substances, that's going to give you a big hint that this is a titration problem. Now what's nice, remember we get to use the same formula that we do for dilutions. So M1V1 equals M2V2. Another way you could write this would be a different formula, but another way, if sometimes students get confused which is 1 and which is 2, it doesn't matter which as long as you pair them up correctly. So if you wanted to remember it as molarity of the acid, volume of the acid times molarity of the base, volume of the base, you definitely could do that as well. The only thing that you need to do additional to your dilution problems would be a balanced chemical reaction, because this is a neutralization reaction. So it's going to be acid plus base yields salt. We're going to swap partners. So sodium is going to now be with chloride, +1 -1. So NaCl plus water, because we are left with OH and H. HOH is just water. So now we have our balanced chemical equation. Ooh. Now it's just a plug and chug. So if it takes 25 mils of a 0.05 molar HCl, there's our acid. So we're going to do molarity is 0.05. Volume of the acid is the 25. We're allowed to leave it in mils as long as both sides have mils. And there's the mils for the base. We're trying to find the concentration of the base. So there's our unknown times 345. So to solve for this, we divide by 345. So pull out your calculators. I'm going to plug this in and get an answer, but I want you to do it as well. So pull out your calculators. It's going to be 0.05 times 25 divided by 345. So our molarity here is 0.0036. Now remember, molarity equals this number. The number needs to have a unit, so you need to put an M at the end of the unit. And there you go, with how to calculate titration problems in this class.